Just wait a moment. So, hi Ravi, hi Divan. Let's just wait for 5 minutes for the evening. In the meantime, I will open the model.
सर एक डाउट था सर मॉडल में
हाँ रवि,
एक डाउट था सर
हाँ you can ask.
आ, आ, सर हम लोग सेक्शन प्रॉपर्टी दिए ना स्टील लोडर में
हाँ हाँ
उसमें सिलेक्शन मटेरियल फ्रॉम डीबी में ई एस अपॉन डी एस अपॉन डीसी और पी एस और पीसी ये इसका वैल्यू और ये क्या है सर कहाँ से है?
एक मिनट मैं खोल के एक मिनट दिखाता हूँ तो शायद मोर क्लियर हो जाएगा।
हाँ
एक
यस
तुम प्रॉपर्टीज में कह रहे हो ना कंपोजिट में।
हाँ यस सर
Let's तो जैसे हम प्रॉपर्टीज में जाएंगे।
हाँ कोई भी एक गडर लेंगे सर
हाँ यहाँ
हाँ
पे जो ई एस अपॉन ई सी आता है ना, और जो ये सब आ रहा है टी एस अपॉन टी सी और डी सी एस अपॉन ई सी, ये डायरेक्ट मटेरियल से ही आ जाता है। वैसे होता क्या है, ये स्टील अपॉन कंक्रीट का होता है। पी एस कोफिशिएंट ऑफ फ्रिक्शन होता है स्टील और कंक्रीट के बीच में, जो कि 0.3 होता है। ज्यादातर लोगों को पता ही होता है, ये भी पता होता है, ये इतना आ जाता है। डी सी अपॉन डी एस जो होता है, इसका भूल गया मैं फुल फॉर्म। ये सब जब आप यहाँ से सिलेक्ट करोगे ना, ये वन ही रहता है टी सी अपॉन डी एस। और यहाँ भी पॉइजन रेशियो वो रहता है 0.2। तो जैसे ही यहाँ क्लिक करोगे ना, ये मटेरियल पूछता है कि आप कंक्रीट को कौन सा मटेरियल लोगे, स्टील का कौन सा लोगे। अगर हमारे पास इफ वी हैव डिफरेंट एनी अदर लाइक पीसीएससी गटर, तो उसमें हमारे ग्रेड चूज करने होते हैं। मतलब ग्रेड कौन सा है कंक्रीट के दोनों, तो उस हिसाब से ये चेंज हो जाता है। मतलब ये होता है, हम चाहे तो अपनी वैल्यू भी डाल सकते हैं, वरना ये ऑटोमेटिक इस मटेरियल को चूज करके हो जाता है। और ये काम आता है आपका लॉन्ग टर्म में। मतलब व्हेन वी डू दी long term analysis na, due to the time variation, creep and shrinkage, that is going to be required these values. Otherwise, if you are doing the normal analysis, then these values do not play any significant role. If you are doing this, because in this program, in this design, we will also consider the time dependent property, like construction stages. If you want to consider construction stages in your design, so these properties are generally important because they are going to use to calculate the theta creep coefficient. So this creep coefficient will going to come from these values, and these are you can say values defined by only our steel grade and the concrete grade. Nothing in this special. Even you can look at it. EC you got it. EC like modulus of elasticity of steel, and EC is modulus of elasticity of concrete. This is Poisson ratio. This is friction coefficient. One TS and TC. I don't know. DC, DCS and DC also. It is full form is there. Just not right now. Even you can select for multiple. You can see even I can select my own creep and shrinkage. But generally, if you're not selecting your own creep and shrinkage, it will be calculated from this thing. So we leave those things to Midas itself because it generally calculate accurately. Otherwise, if you do not want the software to calculate it, so we can calculate by this thing also. So that's why Midas have a lot of options. You can directly use their own properties calculation like the theta and all, or if you can define your own set of calculation, they will do it by own. But it does not affect pretty much in the normal analysis. If you are doing normal one, these thing doesn't, like a single beam you are doing or any building, any cases in which you are not considering construction stages or PCSC losses, then this does not play any important role. If you want, still you can define it, but does not play any role. So here in this, yes, we have, if you remember it, previously we have defined the bracing. I have also joined the bracing, but the bottom one have been remaining. So for bottom one, we need to create node in our girder. Like these are the bottom one. And for this, select this. Also select this. So we will have this kind of. And now if you look at it, I required this to be at this position. Now if you look at the from the top, this gives you pretty much. So these nodes should be connected from this point, like this. So I will select only these node, like I required at this node, or maybe this, this. So I can directly use these nodes. So I just need to push made these node on the girder itself. So here I have checked the distance is 2.2 meter. So just need to go node element, translate, copy. Now here Z 2.2. Now it is asking merging duplicate node in intersect node element. Do not require any other thing. Click on it. So that's how you will get nodes. Now I only need to connect these ones. So I do not require these ones. So I will just select this and I will use this command. So this will be not required. So it will create some confusion. Now you can go into the boundary tab. Boundary, we will connect by rigid link again. Then need to select this one, and this does not require. I think only required at 5. This is 5. No issue. -5. So this will be like this. So we need to connect all these. This one. Others I have already connected, so not required anything. Make sure everything should be connected, otherwise it will give us some error or some beam failure. हाँ रवि, यू कैन आस्क।
सर हमको केवल जो पेडेस्ट्रियल है, जो गर्डर को, उसी को रिजिडली फिक्स करेंगे ना?
हाँ पेडिस्टली रिजिडली फिक्स होता है, बाकी तो बेयरिंग रिप्रेजेंट नहीं नहीं, ये अलग कंडीशन है। इसमें मैं क्या दिखा रहा हूँ, जैसे ये ड्राइंग थी ना, इसमें ये कनेक्टेड है ना एक पूरे गर्डर से हमारी ब्रेसिंग। लेकिन जब मैं डिजाइन करूंगा, आई विल व्हेन आई गोइंग टू डिजाइन इट, सो आई विल गोइंग टू डिफरेंशिएट बिटवीन दिस इज द बीम, दिस इज ब्रेसिंग। तो हम अभी क्या करेंगे, अभी हम ये मान के चलेंगे कि रिजिडली कनेक्टेड है, क्योंकि ये एक तरीके से प्लेट है। एक तो कंडीशन ये होती है कि हम इसको डायरेक्ट कनेक्ट कर दें और यहाँ से हम अपने मूवमेंट रिलीज करा दें। दूसरी दूसरी वो हम करते हैं ज्यादातर अपने स्टैंड में, लेकिन हम मिडास में हमारे पास बहुत ज्यादा ऑप्शन होते हैं। तो हम इसमें क्या करते हैं, सबको रिजिडली कनेक्ट करके फिर जब हम डिजाइन के टाइम पे इसमें से हम अज्यूम कर लेंगे कि ये सिर्फ ब्रेसिंग है और इसमें हमारा कुछ भी मूवमेंट नहीं आएगा, सिर्फ ये एक्सियल फोर्स से जा सकती है। तो ये इसलिए होता है, अभी तो हम इसलिए कनेक्ट करके देखेंगे क्योंकि पूरा ब्रिज जो है सिंगुलर, एक एज ए वन एलिमेंट बिहेव करेगा। तो जब लेटर टॉर्जन बकलिंग और या और कुछ फोर्सेस आती हैं, और जब हमारा स्लैब आती है, मतलब कंक्रीट डाला जाता है, उस टाइम पे ये ब्रेसिंग बहुत इंपॉर्टेंट होती है, वरना ब्रिज इधर उधर भाग जाता है। इसलिए ये हमें अभी कंसीडर करना होता है, क्योंकि जो मेन मेन फोर्सेस हैं अपने गर्डर की, द मेन फोर्सेस कमिंग फ्रॉम द गर्डर which going to be distributed in the our bracing. If we do not connect rigidly, we can connect also by general link also or elastic link, but it is better to connect rigidly. So after the analysis, we can differentiate, or in the time of analysis we will differentiate in between at the time of design. But forces will going to be resisted by the bracing also. It will take the your axial forces and shear forces, but do not take any moment. So what you can do, we can connect by rigidly, or we can release our movements here from these nodes, or you can connect by elastic link also. I do not want to use elastic link. It will create some confusion. So that's why I am using rigid link. Then I have two options. If I'm using rigid link, I can release movement from these nodes. On another option, I will define this as the bracing, and then I will design these things as a brace member, not as a main beam. Main beam will be only this one. So this is just the your different you can say analysis methodologies available. So you can it's up to you which you want to follow. Everyone is okay, but this is the you can say give most accurate results. Even everything
नहीं
if
सर, उनको कंक्रीट डालने से पहले सारे ब्रेसिंग्स और जो क्रॉस गर्डर हैं वेल कनेक्टेड होने चाहिए।
हाँ 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 बिल्कुल, इवन नॉट कंक्रीट डालने से पहले कभी कभार कास्टिंग यार्ड से भी दो दो गटर एक साथ कनेक्ट हुए हुए आते हैं, ब्रेसिंग कनेक्ट लगी भी आती है। क्योंकि अगर आप सिंगल गटर को उठा के अपने लिफ्टिंग करा रहे हो, तो वो स्वे कर जाता है, मतलब भागने लगता है, समझे, ट्विस्ट हो जाएगा हवा में ही, या कुछ और दिक्कत आ जाएगी। अब क्या करते हैं, दो गटर को एक साथ उठाते हैं और वो उसको पहले ही, वो जो ब्रेस करते हैं वो साइड पे ब्रेस करते हैं, और वो दो गटर पहले से ही अपने फैब्रिकेशन यार्ड से बना के लाते हैं, या फिर दोनों को एक साथ ही बना के लाते हैं और वो ब्रेसिंग भी वहीं से करके लाते हैं। इट डिपेंड्स करता है हमारे पास क्या क्या अवेलेबल है। अगर कोई रेलवे पर ब्रिज और तुम्हारे पास ट्रांसपोर्टेशन की जगह नहीं है, एक एक गडर ला सकते हो, या फिर और तुम्हारे पास जगह है आराम से ला सकते हो, तो दोनों को एक साथ ला सकते हो या फिर अलग अलग ला सकते हो, डिपेंड करता है। लेकिन हमें ब्रेस तो करना ही पड़ता है इरेक्शन के टाइम पे। या तो हम टेम्पररी स्टिफनर्स प्रोवाइड कराते हैं हर एक एक मीटर पे, दो दो मीटर पे, और स्लैब बॉटम फ्लैंज और टॉप फ्लैंज को बहुत रिजिडली बाइंड करते हैं, ताकि वो जब पूरा हवा में हो तो मूव ना करे, मतलब ऐसा होता है झूलने लगता है पूरा का पूरा गटर। तो उसकी वजह से भी ये ब्रेसिंग बहुत इंपॉर्टेंट होती है, ताकि मेरा गटर झूले नहीं। दैट कंडीशन इज नोन एज इन इंग्लिश स्वे। इफ माय
हाँ
ब्रिज
ये
does not sway, for sway these bracings are very important, most important the bottom one. Why? Because in top flange after the concreting we have the restraint because of slab, but bottom flange generally do not have any restraint, and this is because bottom flange generally take your bending, and also it is on the higher plate thicknesses, but here plate thickness is more or less same for the upper one is I think 40 mm, and bottom one 45, 50 or 55 something. So that's why we are also putting bracing at bottom flange also, so it will not sway at the time of erection and after the during the live load or wind load or any other load, it will not sway or go from its original position. Then it will be like that. Top flange will be in your perfectly rigid shape, but bottom flange can able to move in any direction. That is a very worse condition. We do not want that condition. Now here only remaining. Where is this? I have not. Yes. This. So this connection represents that my girder are connected rigidly with my bracing. But when I will design it or change my forces, it will mean it will only take my axial and shear forces. Nothing, no other forces will going to be transferred to it. So let's just see if we have provided to every part. Here we have connected. These I have already connected in the history class. So this is fine. This. Everything is connected. Now other part will be your dummy slab. We need to create a one dummy slab also for which purpose? For green concrete, because there will be green concrete load at the time of pouring, because at the time of pouring only steel girder will going to resist your loads. It will not become composite. When concrete load will come, so our girder will behave only steel girder. It does not have any concrete property. But after 15 days, when concrete become harder, then it will become a composite. So that is also important thing in our modeling. So how to represent generally for transverse one is to provide just transverse beam, like from this point to this point. So we can just select our girders. So we have these points available. Let me see. Yes, this is my bearing and diaphragm. Other is my this one. Then I have this one also. Then this one, this one, this one, this one, this. Then I have in the mid these, then these, and then again end diaphragm. So I'll try to create by this point. What we can do, we will first to go into the properties and let me see how much thickness I will try to use. So here thickness is 3 meter. Here I think little bit not. I need to consider this one. This will be fine. But here how much? A little extra, that is fine. 3 meter. This is little bit big. This is 4.4 and this will come to around 6. These will have little bit higher width. These will have the smaller widths. And this one 2.3 I will provide 3 more issues. So I will create 1 6 and what is this one? 3 and 4.5. Okay. I'll create 2 slab. Go into the properties, section property, add. Here solid rectangular, slab 1, user. Now depth will be 0.25 and B will be 1. I am considering 3. Change the offset. And another one will be slab 2 with 4.5. H will be same 0.25. B will be 4.5. So there will be some overlapping, but you can ignore that one. Let me create. node element, create element. Now here is one more option I will show you. This is known as ortho. If you click on this ortho, it will always going to take your beam in straight direction like this. So this is very good option. Like I will create here, then I will can create like this. Then again, if I click like this, then again I can click like this, then like this. So this ortho option is also for the if we have a straight bridge. So this option provide you very good flexibility. So these will be now I will provide this properties and which property I will give. Slab one I will give up to this point and also this one. To this and slab 2 let me click this is so this will be my slab 2. So more or less it will be look like this thing. But one more important thing is this I need to extend those points up to this position. So your brick will look like this because you know there will be extent of slab at this after bearing also little bit. Like if I show you, it will going to extend here little bit also, like at this position up to the expansion joint. How much it is? 1.3 both side. I need to again create that. So just select these nodes and go into the extrude command. Click on slab 1, unequal distance, y direction, 1.3, apply. Okay, there is one extra have been come. Let me why it is showing. Okay, and this is showing because of this. So I do not, I've created wrong point to this one. Delete this. Now I will try to merge. So we can do this thing also like merge and divide. Then I can create another one. And I have to this. Okay, this is something not able to. Now we will go again and shoot everything. This should be slab 1. Select like this. Unequal distance, y direction 1.3. And then again select the these mode minus 1.3. So this is for our dummy beam. I will change the properties of this because this will be my slab 2. Now we will have complete bridge like this. But we have not created the dummy material. We have only created the property. So what we need to do, we need to go again in our property tab, material properties. Here go add. So here what we will do, just click IS, select our again grade like 350 we are using. Now when you select this one, click back again none. So your property going to be look like this. So here change the density 0 and name it dummy. Okay, close this. Now select the cross gutter. Like now simple method is just select like this, and put it. Now if you look at the whole one, the bridge will look like we have only this. These are my dummy beam, and I can also group these dummy beam into new dummy beams because this will go also come use in my live load live load uh, cross beams. So now this is completed up to I think modeling. We can just check
सर हम
one.
लोग स्लैब स्लैब के लिए कर रहे हैं ना डमी,
हाँ
स्लैब के लिए
हाँ,
कर रहे हैं ना डमी।
स्लैब के लिए वो भी सिर्फ इसलिए
तो
करते हैं हम
तो
क्योंकि
मटेरियल
हाँ बताओ क्या कह रहे हो।
तो मटेरियल में सर वो कंक्रीट करना पड़ेगा ना।
अच्छा वो तुम कह रहे हो, ओके ओके। हाँ वो चेंज कर देते हैं, मैं समझ गया। वैसे उससे फर्क तो नहीं पड़ेगा लेकिन हाँ हम कर सकते हैं क्योंकि मैं एक नया कर देता हूँ। तो कंक्रीट में जाके इसको ऐसे कर देंगे, सेम वही मेथड है, मेथड डिफरेंट नहीं है। IRC पे क्लिक करके जैसे हम 40 यूज कर रहे हैं ऐसे क्लिक करके वापस अपने नन पे क्लिक करेंगे तो ये मॉडल ऑफ वेलोसिटी सेम रखते हैं, पॉइजन रेशियो भी, थर्मल कोफिशिएंट भी, बस डेंसिटी को 0 कर देते हैं और डमी नाम देते हैं, ओके कर देते हैं। तो इसको हम डिलीट कर देंगे और इसको क्लोज करके अभी हमने वहां पे ग्रुप बनाया ना तो वो ग्रुप काम आ जाएगा। सिलेक्ट ऑल। So now dummy property created. So this will be your how steel gutter will look like from the bottom also. And there is a gap also. The gap is for the haunch. I previously already shown in the drawings and everything that there will be this gap. So that's how it will look like. Let's just save it. Now I will teach you how to copy. I think previously I have taught you or not, like from one model to another model. This where I have been saving. I've created. Now we are going to copy our load, like we do not need to create every load again and again. So if you have defined one loads in any model, like if you have designed one PCSC cutter thoroughly, so you do not need to make an every time you load, you can directly copy paste. I will teach you how. It's simple. So it will save a lot of time in our modeling and uh, analysis purposes. What is this instance? In time. It is loading. So, like if I have already these loads, so these load will be common. Only pre-stressing will not be there. Otherwise, wet concrete, wind, every load temperature sequence will be same breaking. And even the we have I can show you like load combination we have created. So, what will be the benefit here? I can go in your tools MCT command. When you click on MCT command and you can click here, it will show a lot of everything which is happening in our model. So the load we need to copy is known as static load. So S T, you can search, it will give me STDL load case, static load cases. So it will give like this, and if I click insert data, so it will give me these are my loads. So I can just click copy, and I will come here, go to tools, MCT, click, and I'll click run. So you can see directly all loads have been done. Only I need to assign the value. And the other thing is that the load combination. We can again MCT. So this click L. So L will take you like you will have a lot of things. LC color, LCOM, this thing. So these all are important as per the requirement. So here will be mentioned load combination type and load combination. Load com. So if I mention load com and click insert, I will get directly all the load combination. I just need to control C. Come here again, open the MCT file, click in this, paste, and then click something it is showing. It will have one error. Why the error is? Because here is your live load also. So what I need to do, I need to create live load with the same name. So here the moving load cases are like if I have two class A, 170 R. So I need to create whatever load I will provide, I need to create with two class A and 170 R. So how much width I have considered, you can able to see. From this to this point, it is around 10.1 or 10, 10.1. So in 10.1, I think the remaining one will be 9.1. So 9.1 generally very close to your 3 lane, but lesser than 3 lane. Or now it also depends, if you remember it, there is footpath loading also. If we want to follow this drawing, because in railway over bridges or always the ROBs, you will have the footpath loading also. So we can add footpath loading like this. So the overall deck weight is 10.1. That is it is giving. So here, if you see, the left side have been considered as the footpath loading, and we have also crash barrier loading little bit eccentric to it, so that we can calculate it. But first important is that how much footpath loading. So if you look at here, this railing is give us around. Let consider it 750. So here this we will consider 500, and this will also be 500. So 850, you can say 850 will be taken up to this point to this point. This point to this point is have been 850. So remaining this one will be 10.1 minus 8.5. So it will give us 1.6. So generally what will happen, we consider railing this as a 200 mm. So our footpath become 1.5 if you consider this 4.5. So I will consider this railing as a 100 mm, and the remaining footpath will remain again same 1.5. So footpath width, remember it, generally for ROBs, the width we try to follow, if we have crash barrier and this 1.5, if we do not have crash barrier, like this is open, in this it will become a 900 something. 900 or 800. So this is also one condition. You can see this one, the open one. And with close condition, it is 1.5. With open condition, it is 0.9. So that's one thing. Now we will consider our footpath loading because we need. So what is happening from this to how much I need to consider? 1.6. From this to, and this to this is already available like 1.3. So from this to this point is around 0.3. So 0.3, I need to consider it one more, you can say, I can create it a line, or I can directly apply loads onto my this beam, because this beam will going to take my all the live load. But what will going to be happen now? So I need to create a centricity. Now, if you seeing this from this to this point is, let me show you what I mean by the centricity. I have this kind of thing, and my girder is at this location. This is 1.6, we can assume, or 1.5 directly we can assume. So 0.3 in this direction I have, and 1.2 up to this direction, 100 mm taken by the railing itself. Give me one moment. So now what is going to happen? I need to make this one is here. I consider it not here at this location. So what is going to happen? Because of this half eccentricity in this location, because it is 1.2 in this location and 0.3 your right side location. So this will try to create extra eccentricity about this girder. It will only generate your torsion, but your longitudinal moment will be same. It will not create any hindrance in your longitudinal moment. So if we want to apply it for creating, you can say this is the torsion in this direction. So what we need to do? We need to first of all minus 1.2 minus 0.3. Everyone looking now? So it will give me around 0.9. And this 0.9 from this point, so 0.9 and 0.9 half of it. So divided by this, so it will give me 0.45. So 0.45 eccentricity will try to generate extra moment for my this footpath loading and with the extra SIDL, or you can say live load footpath. So that I will consider it when load. So I will not do not need to create any extra beam or then extra forces. We can directly provide 0.45 eccentricity and will apply the moment accordingly. So another thing is now our clear carriage weight is 7.5. We will try to use 2 class A. And one more thing important is that in the ROBs, we need to create a special vehicle load also, because you have seen that in ROB there is no other way is there. So generally we need to consider a special loading even for 7.5 meter big, because you cannot able to cross your railway line for any special vehicle. Otherwise, there will be another route, a long route may be available or not. So it totally depends as per site. But generally, client asks right now for the new bridges, whatever you are making, everyone asks to consider the special loading. So I will also show you how to consider the special loading also. So first of all, let me create some live load also. Moving load. Again, we can go. And yeah, traffic lane. Now traffic lane, I will consider according to this this beam. We need to consider actually from both end, but if we are considering from this, this is fine, because from this 0.3 I need to leave, then 0.4 we need to leave, so it will become more close to this one. So this will give me the more, you can say, conservative results. So I will consider according to this one. So I will create add. So add lane number 1. Lane 1 eccentricity. Now eccentricity will come from, now for eccentricity again we need to come here. Now if you look at here, this is I am taking as 0.5. So this is have been taken as 0.5. So after 0.5, how much it will remain? 0.8. This will be 0.8. And 0.4 will be taken by directly, like there will be this vehicle, then another tire will be at this position. So this is might be condition, and this center will be from this point to this point, 0.9. So in 0.9, how much I need to minus is remaining 0.4. So it will be 0.5 eccentricity from this direction. So I will provide, I think, 0.5 positive I can check it, and span length is I think 36. Little higher, yes. Center to center is 36.899. How much is it? 36. Center to center is 36, but little extra is there. 36.89 and 50 mm 37 it will be 36.899. And cross beam, then again need to select the group. This to this. Click apply. Now it is showing an error has been encountered. Now it is showing it does not intersect a cross beam. So that is the problem. I do not like it. So how much it was there? 0.5. And if I consider this thing, delete from this to this, then it will be 2 meter. Okay. Maybe I will name it plate 2 and click. So sometime it will give you this kind of error. So you can able to okay, how much centricity it is considering? 2 meter I have mentioned, but it does not look like a 2 meter. This is, let me see it. Okay, okay, something is not correct. So close this again, delete this, delete this. Traffic loading. I need to see again why it is not considering it. Okay, okay, this is not listed. I think everything is fine. Let me change the direction also. So how you can change the direction? Here are also tools or node and property. You can see your beam direction also by clicking this element, local axis, click apply. So you can see x-axis like this, but I want to create like this. So what I will do, I will go into my change property, change, insert elastic material, definition, structure, change parameter. Here you can select alignment, local, standard, this one, and what we are going to do. And click apply. Now if you look at here, all local axis have been changing in one direction. So that is one point generally can able to. I will select again. And I will click this. I will try again and see if it's giving the same error or not. Generally, sometimes it does not recognize this outside beams, so that's why sometimes it will become difficult. So what I need to do, I will go again in my load traffic lane, add lane 1, 5, then I will create from this. I will try to create from this. See if it's giving an error. Okay, created correct. So now another vehicle is required. Another vehicle will be from this center to this 3.5. So this is 0.5, 3.5, 3 meter. So 2 meter have been minus for this one, for this center, and 1 meter more is entered to it. So actually it will become 4, 3.5 plus 0.5. You can click 4 and click the apply button, lane 2. It is created. Man, not created. Sorry. What just happened here? This should be deleted. And 4. Then I need to again select my point like this to this. Name lane 2. Okay, lane 2 should be deleted. Four meter span length. So this will be your another load. Now I will create 70R will be from at this mid tender, but it will give you the maximum effect because of 1.2 eccentricity. So lane 3 for the now lane 3 will be how much eccentricity? 0, but this will be 1.93, and from this point to this point. Okay, let me delete this. From this point to this point, apply. Now now we will discuss about the our if you want to create a special vehicle. So how to create a special vehicle, because a special vehicle will going to be run at this center, at this point, at this center stage. So if you look at the center point, I've created one 70R at this location, but a special vehicle will not take on this gutter because a special vehicle will be equally distributed from this direction to this direction. So I need to calculate this in low 1.3. How much this would be? So 1.3 minus 2.15 minus 1.3. 0.85. So this thing is giving me 0.85. So 0.85, 2.5 minus 1.65. So this distance from this is 1.65. And this we already know it is 1.3. So this, if you look at here, 1.65 minus 1.65 minus 1.3. So it is giving me 0.35 and half of 0.35. So vehicle will be little bit just to half of 3 point, it will be 0.175. So it might be on this girder also, I can consider it. So for that, I can create lane 4, and it will be spacing of 1.8, and this all remains same. Delete this, or what I can yes, delete this. I need to show you one more thing. Again, create like this, apply, and close this. Now we have 4 lanes. This lane 1, lane 0, not able to. 1 and 2 was class A 70R, and lane 4 for a special vehicle. So you will go into the first of all our vehicles, add standard. In standard, class A will remain same. So we will click apply. Have and then 70R apply. So this will create only my 2 lane, but I require the special lane. So does anyone have any idea and previously created any special lane in Midas or not? Hello? Hello? Hello?
हाँ, yes, sir.
Any idea special lane? Have anyone created it? Because this is important one. Generally, if you do any for any international like MNC company work, so you need to create your own vehicle because they have some special loading available. So for this, we need to consider not the standard or this one. We will close that. There is another thing, user defined. So in user defined, it will give us this kind of result. If it's only wheel vehicle, this is fine. Wheel or track, bogie one. Then another one, wheel only, do not have bogie track. Then another one is permit truck. So this is the permit truck. We always use it for a special vehicle. You can name it special. First of all, let me close this and open the code. So this is my special vehicle. Now, if you look at here, this front 3 tire will be 2 tires, and afterwards 18 will be my 4 tires. So that's how we typically going to represent in same way. We will not going to change it. So if you look at here, this tire I will consider at which location? I will tell you. This I can consider up to this one, and this I will consider at this one, these 3 tires, because it will be in the mid position. So 0.9 from both ends. So let me first of all like do like this, and where is my Midas? And this is my Midas. This is the one. This is PCS in this is the one. So this will be the one. Now we'll go into vehicles, add user define. I think this is the one. No? Still vehicle user define. And here will be user define. We will name it permit truck. Then again a special vehicle. Then Excel. So these will be the Excel name. Like you can name it 6 ton, 6 ton. And if you see 6 ton, 6 ton means 30 ton both side. So 30 into 6 ton 3 3. So we need to multiply it for 10 for kilonewton, or if you want very accurate you can multiply it with 9.81, but if you're multiplying 10 it's fine. So 30 kilonewton. Now here is the P1 D1 P2 D2. If you look at here, D1 is the distance, P1 is the axle, and it is mentioned symmetric vehicle, like left and right both will be symmetric. So I will click P1 and I will mention 30, and D1 will be 0.9, and I will click add. So it will come at this position. Then I will create 9.5. 9.5 ton means 950 95 kilonewton. So divide by 2, again it will be 45. So here this I will change into 45 and click add. So it will be another axle. Now 18 ton. Now in 18 ton, if you look the tire arrangement, this is not the one, here it is mentioned. So first wheel from this to this position, 300 plus half of 450, like 225. So 5 225. So here even I will mention now how much it is going to become. 18 divided by 4. 45 again. So 45. This is I think little bit extra. It was the 95. So it is 47.5. You can click on this. Click like 47.5. Click modified. So it will be modified. Then I will click 18 ton. Then 45. So first tire spacing 0.525. Another 45 ton. Another tire spacing should be from this point to this point. So how much it will be? I need to add 300 plus 300, 600 plus 450 plus half of 450. That's how I will get it. So 600 plus 450 plus 225, 1.275. This distance will be 1.275, and I will click add. So here I have created 3 axles like this same one. Now I need to create this one. 1, 2, 3. 3 is this and 19 is this. So it will become 22. So here I will select 1 6 ton, 9.5 ton, then again 9.5 ton. Then it will go 19, 18 ton, 18 ton up to 22. Or if we have already created it anywhere, our special vehicle loading, we can directly also copy paste from MCT command set. So both option of 1 and 22 have been come. So I will go upward. Now spacing. If you look at the spacing, first spacing is 3.2. 3.2. Another one is 1.37. Then another one is 5 point, how much it is? 989 or 5889? Any 889. 5.889. And afterward, all are 1.2, 1.5. If you look 19 into 1.5. So 1.5, 1.5, 1.5, 1. So that's how we need to provide our spacing. Maybe click and delete this again, and just click Okay. So our special vehicle also define it. So we just need this, and for this, let me see this model. Our first load is just naming should be same 2 class A and 70R. So we will go into like moving load case, add. Now before that, we also need to consider our impact factor. So we'll come into the code here. So for impact one, graph have been given. So we will can use directly this one. Now the top one is for the steel one. So this one I have 36-meter span. So this it is giving me around 19. I can consider it 20%
No,
impact
but this
factor.
is for tractor and wheeled vehicle, no, sir.
This one?
This one, this graph.
Yes. This is for the your 70R.
Yeah. You can see that class steel bridge
Yes.
for track
Yes. This is for 70R loading.
and 70R and
this is
class loading. For special
uh,
vehicle, we can consider 1.15. That is there provided in special vehicle class only.
so I'm not considering for special. I'm for right now. If you calculate for steel, which is also by this formula for class A loading, 9
No, sir. I am telling.
divided by.
I am telling for special vehicle only for special vehicle.
Okay, you are telling only special vehicle.
Only special. 1.15 we can take it.
Wait, if you calculate even this one, it will give
No,
you
no. They are provided directly.
Directly.
They are
And
given the
both
special vehicle
are
class.
coming directly same generally.
Yes. Yeah, both are almost same only.
It depends. Some people ask you for a special vehicle to increase 1.15, and for some people they said do not increase it, remain put it at the same. It depends. Generally,
Yes.
because for 7.5 meter
Generally,
width.
generally special vehicle they won't have any impact factor.
Yes. They do not put any impact factor for a special vehicle until unless it is a 3-lane bridge. So for 2-lane, you do not need to provide any additional impact factor for your this one, this special vehicle. But this is a steel bridge. So for this steel bridge, we can able to use that because for steel bridges, impact factor increases a little bit. If you look at due to the graph also, so if anyone wants, we can. That's why I'm little bit also going to increase this one 20%. It is coming around 18%, but we can use 20%. So that is also a good benefit in Meta. Directly we can put it in our live load application, like to class A. And here I need to select this one. So this is my scale 1.2. And here if you see no 70R is coming. So 70R for this, I will show you how it is going to become. Select, apply. So 70 or this one, lane 3, 1.2, lane 1. Okay. Now it is not showing for 70R. That I will create later. First, let me copy the load combination. It is giving anything else or not. I'm just trying to see. Going into MCT. Okay, it is giving like this. I will go into the MCT. Close this. Now it is again giving me warning 44. So you can click here and click enter. I can go here 44. What is the warning here? Dead load, CS, SIDL. Okay, okay. It is showing CS1. Yes. SIDL tender secondary. Okay, because what going to be happen, I will not define my. So I need to, okay, let's just leave this. Okay, I will go into the nodes. So I want to show you how to create a special vector. Here, you need to select this option, load case for permit vehicle. When you select this, a special vehicle automatically come, and this is for lane 4. It will ask you any eccentricity or scale factor. So here we can choose 1.1 side or 1.1 according to our requirement. Our name special vehicle. Okay. And Midas is also one good thing if you read it. Here are multiple, if we have multiple vehicles, so it will decrease our live load accordingly also. So if I have any more than 3 lanes, so multiple present for carriage of 0.9, then 48, it will automatically consider it. So this we have created. Now let me just check with the one load thing. I will go into the static load for self-fade. Just checking the model right now. It will give the correct result or not. Results versus green diagram. Okay. I have gone into construction stage. Okay, no issue. I have live load. It is also not showing something. Is error is there? Does I have not connected everything? That I need to see. Sixty, 61, 35. Where is 60? Is showing this. Sixty-one. Okay. And 35. This is fine. I need to see. Okay, I am not connected with the uh, bearings. I am not defined the bearings. That's that issue. to come back here, come here, select the node, okay. Now for bearing, that drawing also gave us the bearing layout, or if you want to consider your also there for four gutter like this. Same 2 pin, 2 free, then transfer free, all free. So for bearing again boundary, elastic length. So this, and FTX for these two, and the remaining, this will be longitudinally free. So Z will be free, Y will be there. So we will have results. Again, it is not showing. Something is fishy here. What is happening? "41, 43, 37. Why are you concerned?" Okay. Sorry. Why sorry? Because the rigid link, these rigid links are not connected. Only I have connected the bracings. So boundary, rigid body. This will be my master node. Copy y3 @ minus 2.5. So sometime it happens also that we forget about this. Yes. Wait a moment. One thing error also here. Control Z. What will be my error? This rigid link will going to be this and this. Both will connect. Then again this one, this. Okay, no error have been shown. So that is fine. Now you can see everything is fine. So these are the main governing gutters. And now I just need to apply the all other loads. For this is 70, or if I click beam and I will select the special vehicle. For a special vehicle also, this will going to be governed. And if you see the formation, so you can see here clearly these two are going to be deformed more as compared to this. So pretty much accurate diagrams. Now class I will give a more fine error. So up to here, any doubt? So we just need to create this load. So I will create other load and I will show you how to create this one extra load. Is it there? Footpath load. So all other things will remain same. So footpath will have two kind of loads. It not be one load. One will be your SIDL due to the raised slab, because here you will have raised slab. If you look at this location, so this is generally 1.5 raised slab there, 0.5, you can say 0.5, not 1.2. So 1.5, because there will be utilities, cables, sometimes 1.15 or sometimes 2.2 also, like 150 to 200 raised SIDL we need to consider it for the footpath. Then our live load will come for the footpath. So these two load extra here. Other thing, the scratch barrier will be same. This railing load here, generally 5 kilonewton we consider it, but it depends, because this railing sometime also some hoarding or extra you can say protection comes, so we increase it up to this to 8 kilonewton also. So it totally depends. If we are considering little bit conservative side, no issues, because this gutter will not going to govern. Your governing gutter will be this one. So if you're considering it little extra, it is fine. You can show it. We have considered extra loading, because there will be no live load on this gutter. Only permanent load will be here, like SIDL, and the extra 5 kilonewton. Our live load will be here, and the scratch barrier load a little bit also it will be here. So these load we need to consider, then we can able to design it. So up to here, I think it's pretty much clear to everyone. So load combination we will create our own. No issues that are not working because of this this model and that model. Right now it's not similar state. Then we need to create our this thing. Our construction stage is also in the same manner, then it can easily able to. But if you have any other load combination, like without like PCSC gutter to PCSC gutter, then you can same able to use, and from steel gutter to steel gutter, or if you have any RCC gutter or box section, so on those you can copy directly according to the model. So because it is calculating right now brief, secondary and everything, that's why it is not copying. So that is the only thing. So up to here, if anyone has any doubt, they can ask. Or we will continue tomorrow. So, right now, our only model have been completed. So only loads, maybe I will try to apply some load like a wind or temperature one. That will remain same, no change in your wind and temperature, and the change and even the change will be only this SIDL and this. Then we will create our construction stages. In construction stages are also similar to our PCSC gutter kind of thing. Yes, someone is asking.
जाट जी, मैं ये पूछा था कि अब जबकि इसमें जो मेन गर्डर है, जो हमने आई गर्डर क्रिएट किए हैं, उनके डिफ्लेक्शन हमने चेक कर लिए, ऐसे इसमें डिफ्लेक्शन आ गया. If we have to check some other members like आपकी ब्रेसिंग है या फिर अपने
हम सब चेक करेंगे. हम अभी हमारा मॉडल कंप्लीट नहीं हुआ है. हम ब्रेसिंग भी चेक करेंगे. हम स्टील जब तक वो कंपोजिट नहीं बनेगा वो भी चेक करेंगे. और फिर कंपोजिट बनने के बाद भी चेक करेंगे। हम तीनों हर इसका पार्ट चेक करेंगे अभी।
ठीक है।
तो हाँ, ऐसा नहीं है, हम एंड डायग्राम भी चेक करेंगे, सारी चीजें चेक होती है वो, उसमें अपने पास इनपुट है, हम हर चीज चेक कर सकते हैं मडास में। ये खासियत है। और ये डिटेल तो क्योंकि होगा क्या, जो आपका ब्रेसिंग मेंबर्स हैं, ब्रेसिंग जितनी भी है वो डिजाइन होती है अपनी IRC 24 के थ्रू, और जो हमारा स्टील मेन कटर डिजाइन होगा वो डिजाइन होगा IRC 22 के थ्रू। सो दो अलग कोड यूज होंगे इसमें पूरे के पूरा, क्योंकि वो कंपोजिट बन जाता है वो, तो वहाँ प्रॉपर्टीज अलग हो जाती है। और जब वो कंपोजिट नहीं बनता तो वो स्टील होता है, तो IRC 24 यूज करो या IS 800 यूज करो, कोई दोनों सेम ही है, कोई फर्क इतना है नहीं। तो ये अच्छा है, मतलब हम दोनों चीजें बहुत आसानी से चेक कर लेंगे, इसमें कुछ ज्यादा इशू आएगा नहीं। तो जब हम चेक करेंगे तब हम इसको प्रॉपर्टी में लिखेंगे कि हमारी ये ब्रेसिंग है, हमें ऐसे ब्रेसिंग मेंबर चेक करना है। तो जब हम ब्रेसिंग बोल देंगे उसको, तो वो सिर्फ एक्सियल फोर्स और शियर फोर्स के लिए चेक होगी। अगर हम ब्रेसिंग नहीं बताएंगे तो वो उसका मूवमेंट भी लेने लगेगा, लेकिन ब्रेसिंग में मूवमेंट नहीं जाता है, क्योंकि हम शियर कनेक्शन यूज कर रहे हैं ना कि मूवमेंट कनेक्शन। इस वजह से वो हम जब डिजाइन करेंगे वो चेंज कर देंगे। अभी तो हमें अपने मॉडल को स्टेबल बनाना होता है। बिल्कुल वैसे तुम देख भी रहे हो कि if everyone can see, loading is not transferring in your secondary members, only main members have the loading. So that is the why. So if any other person has any doubt, they can ask. So, or we can close it and we will continue tomorrow for the other loading and combination and the construction stages. So, okay. Bye all.